The universe has crazy powerful, massive events that our instruments can barely understand. One of the biggest is supernovas, stellar explosions brighter than whole galaxies. But now, astronomers are seeing something totally new. In 2025, the biggest supernova ever recorded is happening, and it might change how we get stellar death, cosmic evolution, and spacetime. This event has scientists worldwide focused on a star system billions of light-years away. The supernova, called SN 2025Z, is huge and is changing what we knew about dying stars. Usually, supernovas release energy in short bursts lasting days or weeks, but SN 2025Z has had a huge release of light and radiation for over 3 years. Even weirder, it's still getting brighter instead of fading, implying something strange is happening inside. Using the James Webb Space Telescope, the Chandra X-ray Observatory, and ground-based observatories, scientists have checked out the supernova closely. The explosion's energy is immense, rivaling that of whole galaxies. The blast's shape looks odd, suggesting strong magnetic fields or unknown processes are changing how it blew up. Inside this mess is a hypergiant star that was thought to be over 300 times the size of our Sun before it went boom. These stars live fast and die young, burning through fuel in millions of years compared to the Sun's 10 billion. When the star was about to die, its core started fusing heavier elements until it couldn't hold itself up. Gravity took over, and the star collapsed and exploded outward in a supernova. But SN 2025Z is more than just a big explosion. It might be the first pair instability supernova ever seen at this size. In these events, a massive star's internal pressure gets so high that gamma rays turn into electron and positron pairs. This lowers the radiation pressure holding the star up, causing it to collapse and explode, destroying the star. No neutron star, no black hole, just atoms scattered everywhere. There is still an issue. SN 2025Z is still visible, still getting brighter, and making radiation that doesn't fit the pair instability model. It emits not only high-energy X-rays and ultraviolet light but also structured radio waves, which some think might be shaped by a strong magnetic engine, maybe a magnetar, a fast-spinning neutron star with a crazy strong magnetic field. This could mean something survived the explosion, disagreeing with the pair instability idea. Astrophysicist Dr. Lena Rasko, the head of a team analyzing data from James Webb, said at a conference that it is something they've never seen, as if the universe is trying to tell a secret. The radiation from SN 2025Z isn't even. Pulses in a rhythm. Some think it resembles quasi-periodic oscillations, energy waves that might mean the explosion's core is turning into a black hole slowly while still interacting with star stuff. Others claim the pulse pattern might be gravitational lensing, light warped by intense gravity, like from hidden massive things between the explosion and Earth. Some theorists even think we might be seeing a transition between dimensions failing. Supermassive collapses could make holes in spacetime, allowing glimpses into higher dimensions or creating a naked singularity, a point of infinite density visible from outside a black hole. This would change Einstein's theory of general relativity and show that our universe isn't as closed off as we thought. This event opens doors but also raises questions. What happens when stars this big die? Could there be similar stars near our galaxy, maybe hidden in the Milky Way's core or behind dust clouds? If a star like SN 2025Z exploded near Earth, within a few thousand light-years, the gamma radiation could remove our ozone layer, causing extinctions. Some believe Earth has experienced this. High levels of iron-60, a radioactive isotope made in supernovas, are in ocean sediments and Antarctic ice, which means a supernova might have happened nearby about 2 to 3 million years ago, possibly influencing evolution. SN 2025Z seems unique. Its location is over 10 billion light-years away, meaning it happened when the universe was young. But its meaning is immediate. NASA, ESA, and other agencies have dedicated resources to watch the supernova. Amateur astronomers are also invited to share data, which is rare. Scientists expect to get data about massive star structure, core collapse physics, and dark energy from SN 2025Z. Some researchers even think this event could show how matter started. In the milliseconds after a supernova, temperatures and pressures reach levels not seen since the Big Bang. The heaviest elements, like gold and uranium, are made there. Without supernovas, planets like Earth and life as we know it wouldn't exist. SN 2025Z seems to be making more heavy elements than expected, suggesting an odd internal structure or exotic matter being made during the collapse. This makes us think we might be seeing physics being born that the standard model can't explain. What does this tell about the future? It makes space observation important again. AI is now being used on cosmic data in real time, and algorithms are being fed data from SN 2025Z. What they're seeing doesn't always match what they expect. There are anomalies like variations in neutrino emissions, unexplained absorption lines, and space-time measurements that have unknown variances. Could this be a quantum event on a huge scale? Could the supernova trigger something bigger, like a black hole becoming a quasar? Or might it be a primordial black hole, something only thought to exist after the Big Bang? Some whisper wilder ideas that perhaps the pulse emissions from SN 2025Z are artificial. Most scientists are careful, but the possibilities are shocking. SN 2025Z reminds us that the universe has secrets. These secrets are huge, mysterious, and humbling. There are things in space so huge that our best tech struggles to understand them. Supernovas, like star explosions that can be brighter than galaxies, release crazy amounts of energy. But now, some astronomers are seeing something totally new. In 2025, the biggest supernova ever is happening and might change what we know about stars dying, space stuff changing, and how space itself works. This thing, called SN 2025Z, has scientists all over watching. It's super big. It changes what we knew about star death. Typical supernovas blast energy for a few days or weeks. SN 2025Z has been shooting out light and radiation for over 3 years. Even weirder, it's getting brighter instead of dimmer, which means something strange is going on inside. Using powerful telescopes, scientists have checked it out. They were shocked. The energy coming from the explosion is as much as entire galaxies give off. The blast looks weird, not round, making scientists think strong magnetic fields or unknown stuff is messing with how it blows up. This all came from what they think was a super big star, maybe 300 times bigger than our sun. Stars like that live fast and die young, burning up all their fuel in just a few million years. When the star was almost done, its center started combining stuff until it couldn't hold itself up anymore. The star collapsed and then exploded. But SN 2025Z isn't just a big boom. It could be the first time we've seen a special kind of supernova where the star just vanishes. In these, the star gets so hot inside that light turns into stuff, making the star collapse and explode, leaving nothing behind. No star bits, no black hole, just atoms floating away. The problem is, SN 2025Z hasn't disappeared. It's still shining and making stuff that doesn't fit that vanished star idea. Things like strong radio waves, which some guess means there's a super strong magnet left over. If that's true, something survived the explosion, which messes up the vanished star theory. Astrophysicist Dr. Lena Rasko said that this is more than just a supernova. Also, she said the universe feels like it's keeping secret. The light from SN 2025Z isn't steady. It goes up and down in a rhythm. Some think the center is turning into a black hole slowly. Others think big, hidden things are bending the light, making it look like it's pulsing. Even scarier, some think that we're seeing a tear in space. Maybe super big explosions can rip holes in space, showing us other dimensions or a spot where things get infinitely dense. Finding that would turn what we know about space upside down and mean this world isn't as closed off as we thought. This event makes us think. If stars this big die, what happens? Could stars like that be near us, maybe hidden in our galaxy? If a star like SN 2025Z blew up close to this world, it could blast away our ozone layer and wipe living creatures. Some scientists think it has happened before, 2 to 3 million years ago, and that event may shape how creatures have grown. SN 2025Z is far away, meaning it happened when the universe was young. NASA and other groups are watching it closely. Even regular people with good telescopes can check it out. They want to learn about big stars, how they die, and what dark energy is. Some even think it could tell us where stuff comes from. When a supernova happens, it gets super hot, like when the universe first started. That's where heavy stuff like gold and uranium is made. Without supernovas, we wouldn't have things or creatures. But SN 2025Z makes way more heavy stuff than other supernovas. This could mean we're seeing physics we don't know. And that is so great. It reminds us how important space watching is. AIs are checking out the data from SN 2025Z for things we might not see. Could this be a big space thing we've never seen? Could the supernova start something even bigger? Maybe a black hole that shines across the cosmos? Or could it be a failed attempt by aliens to use a star's energy? Whatever it is, SN 2025Z shows us that the universe has secrets. Even with all our tech, we're still amazed by space. Join us as we watch this thing. The biggest supernova ever is a story about the universe. The light shows the powers, the rules, and the of this world we live on.